Okay, so in this video we're going to talk about the wave function, right? We have talked about how a particle works in quantum realm, right? We cannot say exactly where the particle is, but we can say a region where the particle could be lies, right? Only the possibility. So let's take a particle, right? So we don't know exactly where it is, right? We cannot say exactly the place where this particle is, but we can say a possibility. We can say this particle can be in this region, right? This particle can be in this region. So this possibility, right? This possibility, or we can say, to get an idea of the position of this particle, we are introducing a term called wave function. We denote it as psi. Okay, this wave function is basically a function. It will give the details of this particle. It may be a possibility, energy. The characteristics of these particles will be given by this wave function, right? This wave function. Each and every particle will have its own wave functions, right? So as an example, let's take a particle like this. Okay, this is a particle, so it contains some energy. Okay, so this particle will have a wave function which describes its nature, its environment, and its behavior, right? And also let's assume this particle has encountered some photons and take some energy, and it has increased its energy into E2. Now its nature or its behavior has changed, right? So it will have another wave function. Okay, let's assume a particle in a different environment, right? Very different environment. We are talking in next videos about different environments, like 1D box, 2D box, likewise. So this particle will have another different wave function. We talk 3, this is 2, this is 1. So this wave function is basically a function which gives you the details or information about a specific particle, right? It will give you about its position, only possibility, right? Only possibility, its energies, likewise. So what the Schrödinger has proposed is, we can take the energy, right? We can take the energy out of this wave function. I'm pretty sure we have talked about that eigenvalues and eigenfunctions, right? So there is an operator and there is a function fx. If this operator and function connected to each other like this, a and fx equals cfx. This c is a constant, so we call it as eigenfunction. Eigenfunction. This fx is an eigenfunction of operator a. We have talked about it, right? This c, we call it as eigenvalue. This is a constant. So this same thing can be done to our wave function, right? Can be done to the wave function. So we will introduce a operator which is called the Hamiltonian operator. Right, the Hamiltonian operator. So we can connect this Hamiltonian operator and our wave function psi. Then we can get our particles energy and our same function. So you can understand that our psi is an eigenfunction of operator H. This H is called the Hamiltonian operator, and by this, right, by this we can obtain the energy of a particle. Energy of a particle. This is called the Schrödinger's equation. This is called the Schrödinger's equation. So we are going to talk more about this Schrödinger's equation and how exactly get this Hamiltonian operator, how we construct operator, other stuffs in the next video. So I just wanted to give you the basic idea of what is a wave function is and how it works, how we can use this wave function in order to get different details, right? In here we use our wave function just to get the energy of the particle. The same like we can take this wave function and use another operator to take another information. We can use this wave function to get the possibility or probability of this particle in some different range. We will talk about it. So next video we will talk about more about this Hamiltonian operator and this energy factors.